Okay, so today I'm going to be taking a look at the Toolz API documentation. So basically what I'm going to be doing is I'm going to be taking a look at the functions in this library. I'll give you a brief rundown of what they do, and yeah, that's pretty much it. So let's actually get started. Okay, so the first one we have is accumulate. What accumulate does is it takes some binary function, a sequence, and then it lets you specify initial value. So this is very similar to how it works in Python standard library. I'm not really sure why you would want to use this over the standard library one, but let's actually give you a brief demonstration of how it works. Okay, so what we do is we pass in a binary function. A binary function is just a function that takes two arguments. So we can either pass in, let's say, an operation like add or multiply, or we can invent our own. And in this case, I'm going to invent my own. So I'm going to say lambda. And the second thing we have to pass in is going to be a sequence. So I'm going to pass in a bunch of ones. And that's pretty much it. And I'm going to save this into X. Okay. Now, if we check X, as you can see, this is just an object. So what I can do is I can run list on this. And we get back 1, 2, and 3. And that's pretty much how it works in the standard library. Okay, so the next one is concat. And basically what this does is it takes in a bunch of sequences. So a small example here is we have this concat function being run on a list of sequences. Okay, so basically it takes in one sequence, and that sequence can have multiple sequences inside of it. Okay, that makes sense. So let's take a look at how this works. Okay, so basically what I have here is I have list, and I have this concat function, and inside of this list we have sublists. So this one is just this one's just an empty list. Then we have a list with just one element, and we have a list with 2 and 3. If we hit enter, as you can see, we get back 2 and 3. Okay, so next one is concatv, and this one is pretty much the same thing as concat, except you're allowed to pass in multiple sequences instead of just one. And what I mean here is that, as you can see, we're passing in 1, 2, and 3. So we're passing in 3 arguments. In the previous concat, as you can see, we passed in just a single argument, which was a list of several other lists. So I guess that's the difference. So to show you how that works, let me just copy this. So as you can see, we're using concatv, and we're passing in just 3 lists. Okay, and as you can see, we got back A, B, and C, and this is simply because the first sequence was just empty, so it doesn't return anything. Then we have, in the second sequence, we just have the letter A, and then in the third sequence we have B and C. That's fairly simple. Okay, so the next one is cons, and it looks like what this does is it adds an element to a sequence. So it adds an element to the beginning of a sequence. And let's take this. And if we take a look at that, as you can see, we got 1, 2, and 3. Now it says here that what this does is it adds an element to the beginning of a possibly infinite sequence. So in that case, let's try something. So let's do something like this. Okay, so what I did here is I used cons, and what I did is I passed this element first as the first argument, and then I passed in basically an infinite sequence here, which is just going to be it's just going to be a generator that keeps spitting out values from this count iterate tool. So let's run next on X. And as you can see, we got first, then we got 0, then we got 1, and then we got 2. Okay, so now I kind of understand why this is kind of useful. Moving on. Okay, so the next one is count. Basically what this says is it will count the number of items in the sequence, like the built-in len function, but it works on lazy sequences as well. Okay, let's try it. Okay, well, that works. Let's try making this into a lazy sequence instead. Okay, that works too. Now let's see if len doesn't actually work. And yeah, okay, I guess that makes sense. So when you run len, so I guess that kind of makes sense why you want to use this. So if you use len on a generator, it's not going to give you a result, but if you use count on this generator, it will give you a result. Okay, so the next one is a diff. Basically what diff does is it returns the items that differ between sequences. So what we see here in this example is we have 1, 2, and then we have 1 and 2, and they don't exist in this output list, but if we take a look at 3 and 10, as you can see, 3 and 10, because they differ, so 3 is not in this one, and 10 is not in this one. Therefore, they both get returned, and I assume 100 is not being returned because these two lists are not the same size. I believe you have to set a default in order to do that. So as you can see here, we get 100 getting returned, and I guess what happens is the shorter list is getting padded with this default value. Anyways, let's try it and see what we get. Okay, so let's see how this works. So what I'm going to do is I'm going to say diff, and you're going to pass in to this diff function two sequences. I guess you can pass in more if you want, but basically what I'm going to do is I'm going to pass in, let's say, ABC, then I'm going to pass in ABC again, and I guess we can convert this to a list. And we get nothing back because these two are the same. And then we try it again, but let's change a couple of characters. So maybe we can do Q, W, and E. Okay, so basically the way that this works is it returns to you a tuple with, I guess, so this is the first index, this is the second index, and this is the third index. And as you can see, we get Q, so Q and A. As you can see, Q and A, they're different. W and B, so W and B, those are different. And then we get E and C, so E and C, and those are different as well. Let's try it again, but with fewer differences. So I'm going to say A, B, and let's say E. And as you can see, we get back E and C because E and C differ between the two lists, or between the two strings. Okay, so the next thing we have is drop. Basically what drop does is it takes a sequence following the first n elements. So what you do is you pass in a number and a sequence, and it gives you a sequence after so many elements in that sequence. So let's take a look at how that works. So I'm going to say drop, and I want to drop the first two elements, and I'm going to pass in 1, 2, 3, 4. It's converted to a list, and as you can see, you get 3 and 2, and that makes sense because 1, 2, and this is the rest of your sequence. Okay, next up we have first. First just takes a sequence and gives you the first element from that sequence. So let's try it. So we just pass in the sequence. So the sequence I'm going to pass in is going to be just 1, 2, 3, and we get back 1. I can pass in something like, and we get back D. Yeah, so this is fairly simple. I'm not going to waste a lot of time on this. Next up. Okay, so the next one is frequencies. What this does is it takes a sequence and returns back to you basically a dictionary. That's what I think it is. So let's take a look at how that works. Okay, so this appears to be fairly accurate. H appears once, L appears 3 times. Now, what I'm actually interested in is what's the interface to this collection. Let's see. Yeah, so it does look like a dictionary. It just looks like a simple dictionary. Now, here's the thing. I don't really see why I would use this over collections counter. So for example, I can do the same thing like this. So I can do pretty much the same thing like so. So as you can see, this counter collection basically does the same thing. It just takes in a sequence and then it gives you back basically a counter of all of the elements in that sequence. So I don't know why you want to use this, because what the counter does is it actually has a couple of functions specific to it. So for example, I can say x dot, and then I can say most common, and I can say give me the 2 most common elements in this list or in this dictionary. It gives me L and O. So I don't know why you would want to use this. If you know why I would want to use, let's say, frequencies over counter, please let me know, but let's carry on. Okay, so the next one is get. What this does is it takes an index, a sequence, and it just gives you an element at that index. And to take a look at how that works. Okay, so we got back an E. Let's take the 0th index. We got an H, and let's take the... Let me try something. Okay, so that's kind of interesting. So what this does is it takes an index, it takes a sequence, it lets you set a default value for if you get an error. So for example, if you're indexing out of the range of this sequence, what you can do is you can say default. So my default is sorry. So if I index out of range or it doesn't get the value or something like that, you can just make it return something else. Okay, so this one is groupby, and what this does is it takes a key and a sequence. And this key is basically going to group. So in the standard library, the groupby function, the key is actually optional. You can just pass in the sequence and it will group them automatically. But here you have to pass a key. So I guess we can try this. So the key can be anything you want it to be. So I guess I can just say int, and what I'm going to pass in as my sequence is just going to be, I'm going to pass in a list from 0 to 9 100 times. Okay, so we got x, which is just a result of this groupby, and I'm going to do x0, and as you can see, that's the group I got from x. So I can do group 1, 2, 3. Okay, so this groupby and the one in the standard library aren't completely the same. So there may be use cases where you'd want to use this one instead of the one in the standard library, or you'd want to use the one in the standard library over this one. But yeah, just to let you know. Okay, so the next one we're going to be taking a look at is interleave. And basically what this does is it just takes elements from, I guess, you have to pass in a single sequence, but basically what you do is you pass in a sequence of sequences and it just interleaves the elements between those sequences into a single sequence. So as you can see, we have 1 and that gets put here, then we take from 3, that gets put here, 2 is here, and then 4 is here. So let's try it and let's see how that works. And it doesn't take multiple sequences, it only takes one. So I'm going to pass in a list. And inside of this list, I'm going to say A, B, C. And the second sequence is going to be a list. And the next one is going to be a list from 1 to 3. And as you can see, as a result, we get A, 1, B, 2, C, and 3. Okay, so this one is called interpose. And what it does is it takes an element and then it takes a sequence. And basically, the description says it introduces element between each pair of elements in sequence. So basically what it does is it just adds, like, let's say you want to add this element in between every single element in this list, you can do that. So to show you an example, so let's say I want to add a 0 after every single one in this list. Okay, let's hit enter. And as you can see, we added a 0, then a 0 here, and then a 0 here. So I think the thing you should keep in mind is that it adds a 0 after the first element, not before the first element. So yeah, that's a pretty simple function. Let's move on. Okay, so the next one is distinct. So basically what it does is it takes a sequence and then tells you whether or not all of the elements inside of the sequence are unique or distinct, as it says so here. I'm not sure, I'm not really sure what the proper wording would be. Would it be is unique or is distinct? Anyways, so let's take a look at how that works. So we call is distinct, and then we pass in, let's say, and obviously this is going to be false. So as you can see, it's false. Let's remove. So that's true. We can also pass in maybe like a 4. So that's true. Let's try doing a modulo 2, and that's obviously going to be false. So yeah, that's pretty simple. So distinct, if you want to check if your container or if your sequence is distinct or it's completely unique, you can use this. Anyways, let's carry on. Okay, so the next one is iterable. So basically this just tells you whether or not whatever you pass into it is iterable. So let's try it. So let's try passing in the int function. So that's false. Let's try passing in 3. That's false. Let's try passing in the character A. Oh, that's actually true. Let's try passing it itself. And as you can see, isiterable is not iterable. Anyways, so that's a pretty simple function. Let's carry on. Okay, so the next one is iterate. What this does is basically it takes a function. So it takes a function and something. And what it's going to do is it looks like it's going to pass in this something into this function. So this thing is going to get passed to this function, and then it's just going to keep doing that over and over again. So as you can see, yields x, then function x, and then function x, and then function x. So basically it's just going to keep calling whatever is the result of that function on the new function, or it's just going to keep calling that function on the result of the previous function. Anyways, so let's take a look at how that works. Okay, so it's iterate, and what I'm going to do is I'm going to pass a lambda expression here. And what this lambda expression is just going to do is it's going to do x plus x. So it's just going to add to itself. And I'm going to pass in the character a. Okay. So let's call next on this. And we get a, then we get 2 a's, then we get 3, or actually, yeah, we get 4, then it's going to be 8. So basically it's just going to keep calling onto itself. Okay, so the next one is last. So basically what we do here is we just pass in a sequence, and the sequence is just going to return to you the last element from the sequence. As you can see here, the last element in the sequence. So basically it just returns the last element in the sequence. Let's try it. So last, then I'm going to pass in A, B, and C. Close this, and we get back C. That's pretty simple. Okay, so this one is called mapcat, and what it does is it takes a function and a bunch of sequences, and it applies a function to each sequence in sequences and concatenates the results. Okay, so let's take a look at how that works. So what I'm going to do is I'm just going to pass in str as the function, and I'm going to pass as our sequences, I'm just going to pass in A, B, C, and then 1, 2, 3 as strings, of course. And let's close this. Oh, that's okay. So it doesn't take multiple sequences. It takes only. Okay, so I guess this has to be a single sequence. And let's pass this to a list. Okay, so what we got here is we got A, B, C, 1, 2, and 3. So that's something. Anyways, let's carry on. Okay, so this one is called merge sorted. So it says here that this will merge and sort a collection of sorted collections. So I guess before you pass something into this merge sorted function, you have to have it sorted. This says that it works lazily and only keeps one value from each iterable in memory. So let's actually try passing in something that's not sorted already. So let's pass in 3, 2, 4, 1. And in the second collection, let's pass in, let's say, okay, so let's see, we get 1, 2, 3, 2, 3, 4, 1, 4, 1, 2, 3, and 4. So in that case, let's just do a sorted on these two. Okay, and now we actually get proper results. Okay, so basically what this does is just merges 2 sorted collections for you. So let's move on. Okay, so the next one is nth. So what this does is it basically takes the nth element of a sequence. So this is very similar to one we just took a look at. So to show you how that works. Anyways, so as you can see, nth 0, you get the first element, nth 1, you get the second element, nth 2, you get the third element. That's fairly simple. Okay, so the next one is a partition. So what this does is it partitions a sequence into tuples of length n. So this is actually pretty useful. So let's take a look at how that works. Okay, so in this example, what I'm going to do is I'm going to partition this list. So this list has 3 elements inside of it into 2 chunks. And let's see how that handles that. Okay, so what I get as a result is I get 1 and 2. So I got a tuple with elements 1 and 2. And it looks like this partition function, if it can't fit the rest of the elements, it just discards them. So what I'm going to do here is I'm going to set the padding argument to be none. And as you can see now, what we get back is we get basically 1, 2, and then 3, and then some padding value. If you want, you can set the padding value to be a number, for example. So yeah, okay, next up. Okay, so this one is partition all, and this just seems to be alternative to the other form of partition. So what this does is it takes n, and then it takes a sequence. And the description says that this will partition all the elements of a sequence into tuples of length at most n. and the final tuple may be shorter to accommodate extra elements. So basically, what we saw before, where it just dropped the spare elements, what this one will do is it will just keep them. So let's try it. So as you can see, we get 1 and 2, and then we get 3. And the thing you should notice here is that this tuple has 2 elements, and this tuple has 1 element, simply because we pass in a list of 3 elements and we partition it to 2, so it's not divisible by 2, therefore we have 1 spare. Anyways, so let's carry on. Okay, so the next one is peek. And what this does is it takes a sequence, and what this is going to do is it's going to retrieve the next element of a sequence, and then what's going to do is it's going to return the first element and an iterable equivalent to the original sequence, still having the element retrieved. Okay, so let me think about it. So you have a sequence, and then this is the first element, and then it returns to you the sequence as it is. And then you can get the first element from this first variable, and then you can... Okay, so assuming this is what I think it is, you should be able to pass in a generator into this, and it'll still give you that generator intact. So let's try it. Okay, so what we're going to do is we're going to pass in the generator. So I'm going to say x for x in range 10. Actually, is range a generator? I think range is a generator, so I'm just going to pass that in. Okay, so I'm going to say first, and then r is equal to this. Let's check first. So the first element is going to be 0, unsurprisingly, and let's pass this into a list, and that works. So that's actually pretty interesting. So if you ever need to peek in front of a generator, you can always use this peek function. Anyways, let's carry on. Okay, so this one is peekn. So what this does is it retrieves the next n elements of a sequence, returns a tuple of the first n elements, and an iterable equivalent to the original, still having the elements retrieved. So this is pretty much the same thing as peek, except you can use this on multiples. You can peek multiple elements from this. So let's do the same thing. So I think the only difference is you just say peekn, and then I think you can pass in a number here. So I'm going to pass in 5. And this is going to be, I guess, these are going to be the peeked elements. Let's check the peeked elements. And as you can see, it's 1, 2, 3, and 4. And then we can check R, and as you can see, that's the entire range. Okay, so I think I'm going to call it here. So if you enjoyed this video, remember to subscribe and like and whatever, and I will see you later.